So in the survey carried out in 2014, it claimed that 43% of Australians were growing their own vegetables. We need to find out how large a sample would be required for this to be sufficient evidence to show that a proportion of Australians growing their own vegetables grew from 2013 to 2014. And then it says provide calculations in support of your answer. Now that's really important because when I went through many of your answers, a lot of you did not do that. You just gave me a whole lot of text. So the clue is here, we have to provide calculations. Now we know from an earlier question that the difference between the samples, just write this out, samples is 4%. We calculated that back in question 3b. This means that the average, the 1.5 times the average margin of error, okay, so we need to calculate that, needs to be less than 4%. Okay, so we know that is the difference between the samples, so therefore we can construct a formula here. So we could say that 1.5 times. Now we worked out that we know that the average MOE is MOE 1, or the first MOE, plus MOE 2 divided by 2. Well, that's the average MOE, okay? So the average MOE is calculated by adding the two MOEs together and then divided by 2. And that has to be less than 4%, or in this case, 0.04. So we've got a bit of algebra here. So let's put our numbers back in here. So 1.5 times the first MOE that we had, which we calculated when we did the sample size of 1390, was 2.7%. So I'm just going to put in here 0, just put this in brackets again, 0.027. So we've rounded it, but that's okay. Plus the second MOE, which would be 2014. So I'm just going to call that, I don't know, P for probability or something like that. Doesn't matter, any letter will do. That's all over 2. And that has got to be less than 0.04. So what we're actually trying to do is we're going to try and find this value P here. Okay, so that's where, that's the margin of error for the 2014 sample. So we're going to do a bit of maths here now. So to get rid of this 1.5 over here, we have to divide by 1.5. If we divide this side of the equation, so if we divide this side of the equation, as indicated by my red dot here, by 1.5, we also have to divide this side of the equation by 1.5. So we'll do that. So we'll divide that by 1.5. And if we do that, 0.04, we get it equaling to 0.026 recurring. So we're left with this part of the equation. Now we need to get rid of this 2 here. So we multiply both sides by 2, times 2. That means we're left with 0.027, that's a 7, plus P is less than 0.053. And there we can solve that P must therefore be less than 2.63%. 63%. Okay. Now, we haven't quite finished yet, because then we've got to use our sample size formula. Remember, the MOE, or the sample size, is equal to 1 over the square root of n. In this case here, we know that our margin of error is, we have 1 over the square root of n is less than 0. We're just going to convert that percentage back into a decimal, 0.0263. So therefore, when we rearrange this, 1 over 0.0263 is less than the square root of n. So if we square both sides to get rid of the square root, so now we need to square both sides, we end up that our n value has got to be greater than 1442 or 1442.08, and because we're dealing with people, therefore that's our sample needs to be bigger than 1443 people. Okay, so that's how you'd work out that particular question. If you got down to this point here where you've worked out the p-value, that margin of error for the new sample, that would get you a J. And then if you could correctly work through this section here, showing correct working, that's worth an I.